This video is about introduction to new set of numbers. Those are called as complex numbers. But before we talk about these, there are a few things that I want to remind you. And this is something you already know. Have you seen number line already in school, right? So number line where you have 0 at the center, then you have 1, 2, 3, all the positive numbers on one side, and then you have -1, -2, -3, all the negative numbers on the left hand side of the 0, and this is called as a number line. Now, say if I ask you that what is the value of square root of 2, you can easily use a calculator and find out the value is 1.414. Okay, it's a standard value also. Supposing if I ask you negative square root of 2, the answer is negative 1.41. Okay, and if I have to place these values on a number line, where are they? If you want to plot, write down the square root of 2, that will be 1.414, which is between 1 and 2, somewhere here. It's close to 1.5. That's square root of 2. Okay, that's this value here. Negative square root of 2 is minus 1.414. It will be between these two. That's negative square root of 2. Now, before we start talking about complex number, I want to just tell you a little bit of story. Okay, this was back in time. Okay, some 200 years back, there was a car and designer or an automobile engineer. He was designing his car. Now you listen to the story so that you can understand this concept better. That this guy was designing the car, okay, and while he was doing his analysis, he came up with an equation, and the equation was x square plus 2 is equal to 0. This was the equation. Do you know that x is called as a variable, and variable can have different meanings over here? Say x, in this case, in our equation, the value of x is nothing but the vibrations in the car. So for a designer, it is very important that how much vibrations that it generates while at a certain speed. Okay, so he was trying to find out the value. So he wrote x square. So he's trying to find out the value of x. So x square is equal to -2. Okay, then when you take a square root of this, if I take a square root here, okay, square root on both sides, I will get x is equal to square root of -2. Okay, now as soon as you get x is equal to square root of -2, now I want you to understand the problem with this automobile engineer doing this designing. Okay, he got x value which is under root of -2, and now this value simply cannot be put on this number line. There is simply no space or no location where I can write down square root of -2. Do you understand the problem? Now, as soon as you get something like this, you probably have already heard of this, that square of anything cannot be negative. So when you get square root of negative number, now this situation, okay, is it already told you in the school that it is invalid? It is invalid to get square root of negative numbers, right? Now in this situation, what he must have done, imagine the story. This was something like, 200 years back. If you get answer as x equal to square root of -2, okay, this was straight declared as invalid. Now, I hope you understand the problem, that there is absolutely no space, okay, for writing the value x equal to square root of -2. Now, in that case, okay, what we have to do is we have to go back in the history. And if you are already aware of this, hopefully, that the numbers were always, when we started first counting things, okay, that's where we came up with the numbering system, right? So the numbers were like 1, 2, 3, 4, basically used for a counting purpose, and all these numbers we call them as a natural numbers. Okay, so these are the natural numbers. And do you remember, do you know the story that even 0 wasn't existent then? Okay, 0 was given by an Indian mathematician. The name is Aryabhat, and when he gave this 0, the number became 0, 1, 2, 3, 4, and so on. And now these are called as whole numbers. I hope you're already aware of this. Now, I want you to understand few things with the help of this. Look, you have to imagine that you are at the time when 0 was just invented. Okay, we only had whole number. Of course, we did not even have negative numbers then. Now you tell me, with all these numbers, when we do, say, an operation like 4 divided by 2, when we do this operation, the answer is 2. Okay, but when we do 3 divided by 2, now what will be the answer of this division? Now I want you to understand, when you do 3 by 2, okay, yes, now you know the answer is 1.5. But back then, when you never had a number which is between 1 and 2, After 1, the next number you have is 2. There is no 1.5. So 3 by 2 was also an invalid operation. I hope you can understand, right? So because the number system was not complete, okay, you cannot say that, the people used to say that back then that this operation is simply invalid, right? And I want you to draw a parallel, okay, or find similarity between the story with this person here, okay, that his answer, which is square root of -2, is declared invalid simply because there is no number, okay, or there is no place to fit that square root of -2. Okay, so and a similar situation has happened in the history, that when we did not have the fractions, or the we only had the whole numbers and natural numbers, even 3 by 2 was invalid. Okay, what else is invalid? Supposing if I do 2 minus 3, okay, when we have only whole numbers and no negative numbers, 2 minus 3 answer is invalid, because we don't have negative numbers. So then we did the evolution, okay, of the number happened, and then we came up with the integer numbers. We usually write it as Z like this. Okay, integer numbers were all negative numbers included: -3, -2, -1, 0, 1, 2, 3. Okay, these are all set of integer numbers. Okay, and even then we had simply nothing between 0 and 1, and between 1 and 2 there is absolutely nothing. And eventually we've realized that the numbering system can be complete when we reached here. Okay, and then this was the real number line, and we started calling this as real numbers. Okay, so once we get to the real number part, now we have the values between 1 and 2 also, so there is no gap anymore. Okay, it's all filled up. Okay, and then we come to this level, and we call these number as a real numbers. Okay, but with the real number also, even when the line is completely filled, and then there are infinitely many numbers between 1 and 2, and so on and so forth, okay, you still don't have a place for that square root of -2, and you're calling it invalid. Okay, so either the calculation of this person are wrong, okay, that's why he's getting invalid answer, or maybe your number line is not good enough to accommodate this number. And the later what I said is true. The number line is not good enough to accommodate this. Okay, so this answer, is it really invalid? And the answer to that is, it is not invalid. Okay, the problem is not with the calculation, but the problem is with the number line itself. And the number line, okay, is not been able to accommodate the square root of -2. And for that, we've came up with the solution. So now I'm writing in blue color. Okay, you pay attention to that. Okay, first of all, we will do a definition, or we will define something. And the definition is, we're going to call square root of -1 as I. And that is just the definition. Okay, we all agree that whenever we get square root of -1, we are going to call this as I. All right. We also know that when you have square root of A times B, okay, you can write this as square root of A into square root of B. This is a simple rule of algebra. Okay, so now with knowing this, if I have a square root of -2, okay, can I write this as square root of -1 times square root of -1 times 2? -2 is -1 into 2. And once you get the square root of A into B, I can use now the second formula, this one over here. Okay, this we already know. And I can write this as square root of -1 times square root of 2. Now, square root of -1 value is already I. Okay, that is as per the definition over here. And square root of 2, we already know square root of 2 is going to be 1.414. So do you see this is I 1.414? Now, what happens is, when you define square root of -1 as I, okay, you can now write square root of -2 as I 1.414. You see that here? So to accommodate this square root of -2, what we're going to do is, instead of having just one line, okay, we will have two lines like this. Pay attention to what I'm saying. That and on this line, like over here, you have 0, 1, 2, 3. On this blue line, you will have 1I, or you will have 2I. Then you will have 3I, and so on, dot, 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 like that. And on the downward side, you will have -I, and -2I, -3I. Okay, so if I declare a second line like this, okay, And with the two lines, this is not a one dimension, it becomes 2D, right? Where you have two lines here. One is a horizontal and another is vertical. Do you see I can now fit I 1.414? Now this is the value of square root of minus 2. Okay, and I 1.414 is just going to be between I and 2I. So say this is the point where you will have square root of minus 2. Do you understand the problem? That initially when you get square root of minus 2, okay, you had no place to write that down. Okay, so for that reason, I have started with this definition and I said square root of minus 1 is going to be I. Okay, with I design one more line, okay, and I get a new set of numbers. Okay, and these new set of numbers, we call them as the imaginary numbers. Okay, so imaginary numbers are basically written in terms of I, 2I, 3I, like that. And once you get two lines like this, you don't have to call square root of negative numbers as invalid. They are absolutely valid and you can write them down like this. Okay, and then similarly, supposing if actually when you take a square root, this is going to be plus or minus, right? So this is square root of minus 2 we figured out. Tell me about this now. So what if I have negative square root of minus 2? Okay, let's do this procedure again. Negative, outside sign, square root, minus 2 is going to be minus 1 times 2. Okay, so this will be minus square root of minus 1 square root of 2. So this is going to be minus square root of minus 1. We've decided to be I. So this value is going to be I. And this is 1.414. That's the value of square root of 2. And if I want to write minus of I 1.414, that is going to be between minus I and minus 2I. So that is going to be here. Okay, this is minus of square root of minus 2. Okay, so that way now we are actually evolving our number line, and we are getting, now we can even deal with the square root of negative numbers. So when you have a real and imaginary as two lines here, okay, this is a 2D plane, and this plane is also called as a complex plane. Okay, this is the plane of a complex numbers. Complex numbers has got a standard notation, and we write down complex numbers as Z, and that's the universal notation for complex numbers. And a complex number typically look like Z is equal to X plus IY. So we usually write down complex number as Z, and they are of the format X plus IY. Now let me write this, do the labeling for this one. The Z here is called as a complex number, and the X here is called as a real part of complex number, and Y is called as imaginary part. I am for imaginary part of complex number. Okay, so now I'll just give you a few examples just to make you understand these things better. Let's say Z1, that's my first complex number, is say 2 plus 3i, and Z2, the second complex number, is say minus I, and Z3, the third complex number, is 1 minus I, and Z4, the fourth complex number, is, let's say, minus 2. Okay, now with all these examples, okay, you can easily plot complex number on 2D plane, or that plane is also called as a complex plane. So the horizontal line, that is the number line that we already know from school. This is the real number line, and the vertical line is the imaginary number line. Okay, so I can write this as 1, 2, 3. This is going to be I, this is 2i, this is 3i, and so on. This is minus I, minus 2i, minus 3i. On the other side, it's going to be minus 1, minus 2, minus 3. So the horizontal numbers, the horizontal line numbers are all real numbers, and the numbers along vertical lines are all imaginary numbers. Now, what I'm going to teach you here is there is a graphical way of representing these complex numbers. So when you have Z1 as 2 plus 3i, understand this 2 is the real part and 3 here is the imaginary part. So when you have to represent Z1, which is 2 plus 3i, we will take the real value as 2, which is here, and imaginary value as 3i. So this is 3i and this is 2. and their intersection point over here, this is Z1. Z1 is 2 plus 3i. It can be plotted. So basically a complex number can be a point on a complex plane. So that's how your Z1 is going to be. Now for Z2, which is minus I, the Z2 number has a only imaginary part. There is no real part. And minus I, we can see it over here. That's the Z2, the second complex number. Now think about it. When I want Z3, the real part is 1 and imaginary part is minus I. So it is 1 minus I. So you will take real part as 1 and imaginary part as minus I. So the point of intersection is going to be here, and that is your Z3. That's the third complex number. And Z4 is just minus 2, and Z4 is going to be here, right? That's the fourth one. Okay, so you can basically plot any complex number as a point on a two-dimensional plane. And this way of plotting complex number, this diagram itself is called as Argand's diagram. Okay, Argand's diagram is a way of expressing a complex number on a 2D plane like this. And there are a few things that I want you to understand, that when you have Z2, do you see the real part here is 0? Okay, so now this type of a complex number is called as purely imaginary numbers. When you have a real part 0, we call it purely imaginary. I'll write down, when real part equal to 0, we call it purely imaginary. Okay, so similarly, if you have this, if you see Z4, it is minus 2, and then there is no imaginary part, right? The imaginary part is 0. This is just 0i because it is not there. So this is called as purely real number. Okay, so when imaginary part is 0, we call it purely real, RE for a real and IM for imaginary. And this is a complex number which has got a real part which is 2 and imaginary part which is 3.